a very happy new year to everybody. I wonder what 2006 has in store for us, but I'm quite sure it's going to be exciting. For our first programme, we're going to go to the outskirts of the solar system. The New Horizons probe is about to be launched toward Pluto. Also, very interesting news from a couple of comets. First of all, our news notes with Chris. And we begin this time, Chris, with some very good news.
Yes, it couldn't be better. The European Space Agency, or rather the governments that make up the European Space Agency, including our own, have approved a new programme of solar system research called Aurora. In particular, in the early years of the next decade, the largest European lander ever to go to a different planet will touch down on the surface of Mars. It's called ExoMars, and it's going to be really exciting. Now, work starts here to work out what we want to put on the rover and to build it. 5 years may seem like a long time, but it's really not for a spacecraft.
And we can give regular reports on the sky at night, I think.
Absolutely. We'll be touching base with the Aurora scientists every few months as they start this process of building something that's going to end up on the red planet.
And is there any life on Mars? Well, Aurora may well tell us. What's your bet, Chris?
Well, I think there might be some primitive life there. I'd really like to believe that there is. As to where it came from or how it evolved, that's the next set of questions.
It may well be there, and before long now we should find out. We can't resist now showing you one of the best pictures ever obtained from Hubble, I think. This is the Crab Nebula, the results of a star that was seen to blow up in 1054. Look at this picture, Chris.
Yes, you said that it's a supernova that blew up in 1054. Of course, it happened 6,000 years before that, and it took that long for the light to reach us. But look at what it's left behind. Glowing gas, even all kinds of structures that Hubble can peer right into the middle and reveal the detail. You can see it with binoculars this month. It's a faint misty patch, but this is the real thing.
In the same field as the star Zeta Tauri, if you want to find it.
That's right. It's an absolutely incredible image, though, isn't it?
It is. Another one, this planetary nebula image. Look at this.
Yes, it's from the Gemini telescope on Hawaii, and it's the Twin Jet Nebula. You can see why it's called that. A small star, maybe the size of the Sun, is buried in the centre there, beneath that glowing gas, and it's puffed out its outer layers and produced this marvellous structure, a planetary nebula.
We are getting now amazing results from these telescopes, and more to come in 2006, that I'm quite sure.
Absolutely.
Chris, thank you very much. And now on to our main programme. I'm sure you remember that the Deep Impact probe crashed into comet Tempel 1 some time ago and produced spectacular displays, and many interesting results are coming back from there. One man who's deeply involved is Professor Mike Ahern at the University of Maryland. Welcome to the Sky at Night.
Thank you,
I was fascinated by that one headline. We used to be afraid of comets. Comets are now afraid of us. But there was no danger of destroying the comet, was there?
No, there was no chance of destroying it or even changing its orbit at all.
What exactly was the main purpose?
The main purpose of the mission was to try to understand the difference between the surface layers of the comet and the interior. We have remote sensing observations of the surface, but we don't know how that relates to the inside.
Some people won't know exactly how a comet's made up.
Well, it has, since about 1950, been called a dirty snowball.
Yes.
It's now perhaps closer to a snowy dirt ball, since there's more dirt than snow, but it is basically the idea that Fred Whipple came up with in 1950 is still correct.
Well, of course, Deep Impact, the probe, had been a total success. Now, I wonder whether you take us through it, Mike.
Sure. We launched in January of 2005, and we went halfway around the sun for 6 months, and then passed in front of the comet, and the comet ran over the spacecraft at 10 kilometers per second.
How big was the comet?
The comet has a radius of 3 kilometers. It's an irregular shape, but it's an average radius of 3 kilometers.
The nucleus was, in fact, dark.
Yes. If you look at a picture of the nucleus, you can see a few very bright areas. They're only somewhat brighter than the rest of it. The very brightest areas are almost as bright as a charcoal briquette, and the average is substantially less than a charcoal briquette. So it's really very, very dark. If you took a picture of the comet nucleus and one of the asteroids we've been to recently, put them together, you wouldn't even see the cometary nucleus because you couldn't expose the camera properly to show them both.
What are the smallest features you can see there?
The smallest features you can see on this picture are perhaps 20 meters across. We have later pictures taken right in this area where we impacted, And the smallest features you can see there are almost small enough to put your arms around.
Well, some unexpected things, those outbursts from the comet on the way in.
Yes, we were very surprised at the number of outbursts. We've known for a long time that comets do undergo outbursts, but
Why?
we thought they were infrequent.
Why?
And we had no idea why. Well, we had 20 different ideas why. As we approached Comet Tempel 1, we saw 6 outbursts in the last 6 weeks. That's far more frequently than anyone had expected. 3 of them occurred at the same rotational state of the comet. And that tells us that many of the explanations for outbursts that have been invoked in the past must be wrong. Solar activity can't be correlated with the comet's rotation. Impacts by meteors can't be correlated with the comet's rotation. So almost certainly it's the buildup of something volatile inside the comet that causes the outburst. Build up a layer of ice very near the surface, bring it into sunlight. 3 of the outbursts occurred very near sunrise in the part of the comet where we saw the outburst. So almost certainly it is something from below or possibly frost on the top that is leading to the outbursts.
What happened when Deep Impact hit?
Well, we came in very obliquely, so we tunneled underneath the surface. We vaporized part of the impactor, vaporized part of the target, and a puff of material blew its way up through the surface. That came out and moved away very rapidly. That was a small amount of material, perhaps 10 tons of material, and we observed that it was very hot material. Then the rest of the material is excavated mechanically by the shock wave that went through. That came out much more slowly, and that came out very cold. The hottest material that came out later was room temperature. Most of it was perhaps, minus 73 centigrade.
What about the crater produced?
That's an interesting story. The crater we never did see because the dust and the ice came out as all very tiny particles. We expected it to be a mix of large and small particles, but because it was all small particles, there were too much cross-section, and we were never able to see through it before we flew by. We think it was 100 to 200 meters in diameter, based on a number of indirect arguments, but we don't have a picture of it.
You have some of the latest images.
I do. I have, for example, a movie made up of the images taken right after the impact, and you can see a tremendous shadow as the impact happens and the ejecta come out. You see a tremendous shadow. That tells you how much material was ejected. You can't see through it at all. And that's part of the reason we never saw the crater. There was just so much small material that it was a completely opaque wall. There are rays, but no clumps of material. It's just nice, uniform, smooth rays coming out. And this shows up in all of the images.
What was seen from Earth?
From Earth, they saw a big increase in brightness, and they also saw large changes in the chemical composition. The Earth-based observers are still working on trying to understand the molecular species that they saw. Most of them were molecules that have been seen normally from comets, but there are a lot of unidentified features that still have to be identified.
What are the main constituents of a comet?
The main constituent is water. After that, the main constituents that become gas that are easy to identify are methanol, which is a simple alcohol, carbon dioxide. We can't normally observe that from Earth, but our spectrometer on board the spacecraft observed carbon dioxide, dry ice. There's a very large amount of that in the comet.
Were there any real surprises?
The biggest surprise was huge amount of organic material below the surface. After the impact, we observed far more organic material, all the stuff you need to make life on Earth. We knew there was some of this in comets all along. There appears to be much more of it than we had realized.
What more have we learned from this about the evolution and history of comets?
The interesting thing is that the entire nucleus is extremely porous. It's 75% empty space. And that means when you make the comets 4.5 billion years ago in the Kuiper Belt, you have to bring things together very gently so that they don't compress the interior considerably. So that's probably the biggest direct implication that we've figured out so far on the formation of comets.
Everything on Tempel 1 seems to have gone perfectly. Is there anything you wanted to do but didn't?
There is one thing, we did want to see the crater. That's about the only thing that we didn't do that we wanted to do.
Well, this first one was a real triumph. Everything went right. Mike,
Yes.
congratulations.
Thank you.
Very much.
Thank you, Patrick.
Let's stay now for a bit with comets. They are not all brilliant things with long tails. Some are very small and insignificant, but they've told us a great deal, and we're learning more about them because probes have been there. And one probe, Stardust, had been out to a small comet, Comet Wilt, and is now actually on its way back. Welcome now to one of our old friends, Dr. Mark Kidger, and also Dr. Simon Green of the Open University. Well, Stardust is a fascinating mission. Will you take us through it, Simon?
Yes, well, Stardust, essentially the mission had two parts to it. One was the flyby of Comet Wilt 2, which was the closest distance, at least the one which we know precisely, at about 240 kilometres from this nucleus, a few kilometres across. But going that close, they put the spacecraft in great danger, and it's precisely that great danger is the thing you need, because you want to collect the dust particles that are emanating from the comet coming off with the evaporating ices. We had a sensor on one half of the front shield in front of the main part of the spacecraft. And we also had a second sensor on the shield behind. There were about 5 layers of shields between the impacting particles and the sensitive parts of the spacecraft. And 1 centimetre particle would have gone through all of them. We had 7 particles that went through the thickest first shield, and they were at least 1 millimetre in size. And we estimate the largest one on the spacecraft as a whole, based on our information, was 4 millimetres in size, so getting very close to that critical size. But of course, it's not what's hitting the spacecraft that counts, it's what's hitting this collector to come back to the Earth, which is the second phase of the mission. And that collector you might think of as a large tennis racket containing, between the strings, essentially containing glass, but not just ordinary glass. This is very, very low density, spongy, porous glass. And the idea of this is to slow the particles down from their flyby speed of about 6 kilometres a second without heating them up. And that's the key thing. We want to bring back these dust particles as unaltered as we can so we can study their composition and structure in the laboratory.
When's it due back?
15th of January, about 3 o'clock in the morning Pacific time, and it's going to land in the desert in Utah and hopefully come down softly on a parachute.
Therefore, the landing procedure is not the same as it was at Genesis.
Not quite the same. With Genesis, there was a stunt helicopter to catch the parachute as it came down. With the case of Stardust, it will just land on the ground, but we hope what will happen is the parachute will open, and then the probe will be searched for after it's landed.
We've got results already from the results of the flyby. What have we learned from that?
Well, they were very interesting because the dust detector that was on board Stardust had about 100 times the time resolution that the detector on Giotto had. And this allowed us to see very small scale structure as we flew through the comet. And what this showed us was that there wasn't a nice smooth distribution of dust flowing out from the comet. It was collected together in bunches, clouds of particles, and each time we flew through a cloud we saw a very large number of impacts and then went down to almost nothing again. And this has told us that these clouds must have resulted from the breakup of larger particles after they left the surface of the comet. And that's very interesting because that gives us confidence in our view of cometary dust as being a collection of very small dust particles stuck together to make larger ones. Now, therefore, if this is common on the surfaces of comets, then what we saw with Deep Impact, or rather what we didn't see with Deep Impact, which was the impact crater, was perhaps not so surprising, because with the very high speed impact of the spacecraft hitting Tempel 1, the large cometary particles that were present on the surface would be immediately broken up into their tiny little constituents, which then left the surface, and they're very, very efficient at scattering sunlight, and therefore it would be impossible to see through them to the crater that formed them.
What do you make of the structure of Comet Wilt?
It was a surprise to me because before we got there, we had a feeling that Wilt 2 would be have an old surface. It had a close encounter with Jupiter in the 70s, so it's only had a few passages close to the Sun, and we thought the surface would be battered with craters and telling us something about its early history out in the outer solar system. It certainly doesn't look like that at all.
Now, one thing strikes me, though. We've now seen various comets in close up, beginning with Halley and now ending with Wilt. And these comets are not all the same. They're quite different.
I'm afraid that's true. That's absolutely, totally different. In fact, going to the example of Wilt 2, even the two faces of Wilt 2 are completely different. And if you put together the photographs of the 4 cometary nuclei that we've seen, Halley, Wilt 2, Borrelly, and the latest one, Tempel 1, really it's very hard to believe that they're the same kind of object. Which one is the real comet?
The kind of processes that we presume have shaped the surface of comets since their formation are early on, when they're in the outer solar system, they'll be bombarded by galactic cosmic rays and ultraviolet radiation, which would chemically process the ices on the surface and maybe redden and darken them, and of course collisions in their source region. And so we would expect the surface to be covered with craters, maybe with frosts where material has come from a crater and then recondensed on the surface. And then later on in the history, if they come into the inner solar system, they may have had a close approach to a planet, been tidally disrupted and re-aggregated, so seeing the evidence of a rubble pile formation. And then when they get close to the sun, we should see the evidence of heating on the surface and successive layers being removed. So all those competing processes could potentially make what was initially a series of comets look very similar, look very different at the time we can observe them.
We've heard a great deal about organic materials in comets. Well, organics, people associate that with life.
Yes, because organic material contains carbon, and carbon is the essential part of organic living material, if you like. But of course that doesn't mean there's living material in comets.
Definitely not.
But they may contain the very earliest building blocks for the material that eventually went up to make life on the Earth, and maybe elsewhere too.
So let's turn now to the outer part of the solar system and the departure of New Horizons for Pluto. Mark, can you take us through the New Horizons programme?
Yes, this is going to be absolutely momentous here. I wish Simon the very best of luck with Stardust, but the mission to Pluto is really something very new, because it's the one part of the solar system we haven't explored. It will make a flyby of Jupiter in February or March 2007 and then swing off to Pluto. Now, the idea is to arrive at Pluto in 2015, summer 2015, and to investigate Pluto and Charon very carefully. It's got 7 science instruments on board. There are a whole series of aims, but for many people, the biggest one is to look at the atmosphere. Now, this atmosphere of Pluto that appeared when Pluto was at perihelion is behaving in a most peculiar manner. People expected it to freeze out, to freeze down onto the surface, disappear. It's still there, and in fact it's actually warmer now than it was a few years ago, which has been an amazing result. Nobody quite understands why.
We've got to understand now that, of course, Pluto has a very eccentric orbit. At perihelion, as it was in 1988, it's actually closer in than Neptune, but at aphelion it goes much further out, of course it gets very much colder.
Exactly, and Pluto, to a large degree, does behave exactly like a comet. That when it gets close into the sun, it develops this atmosphere, the surface methane ice sublimes, forms an atmosphere that's reasonably dense, and then it freezes out again as it goes away from the sun. Now, we expected this to have happened long ago. Now, people are hoping the atmosphere will still be there in 2015 when New Horizons arrives. Even if it isn't, they want to study the surface, map the geology. What kind of object is Pluto, really? Because it is a most peculiar, unusual object. Just how similar is it to other bodies of the Kuiper belt?
Well, the atmosphere is there, but quite extensive, but the atmosphere is very, very thin.
Yes, that's certainly true, and one of the ways in which you can detect it and measure it, of course, is to look through it back at the Earth. And part of the encounter geometry is such that the spacecraft will fly past both Pluto, where we know at least there has been an atmosphere, and Charon later on, looking back towards both the Earth, sending signals through potentially an atmosphere, and looking at the sun, shining the sunlight through the atmosphere, and that's a very, very narrow trajectory to take it through the shadows of both bodies.
Just in case some people don't know, Pluto is actually much smaller than our moon, much smaller than any planet, and Charon, the satellite, is half the diameter of Pluto, so I think it's really a double body.
Yes, exactly. In Pluto and Charon, the difference in mass is only a factor of about 6. The next smallest in the solar system is the Earth and Moon. The Moon is 81 times less massive than the Earth. And after that, you have to go to Jupiter. And Jupiter, it's 3,600 times Ganymede. So really, Pluto and Charon is a quite exceptional body. It's a very peculiar system.
Pluto is not the only traveller in those remote parts of the solar system. There are others. Long ago, first Kenneth Edgeworth and then Gerald Kuiper suggested there might be bodies of small objects out there, and they do exist, making up now what we call the Kuiper Belt, and Pluto is the largest member of that belt.
Yes, and that belt is actually much more extensive than the asteroid belt in the inner solar system, and the bodies are potentially much, much bigger. And Pluto is just one large example of many hundreds of thousands of bodies that we should be able to detect.
Not even the largest.
Not even the largest anymore, no. There's one body which has already been detected, which is larger, and there must be many more lurking out there.
And are they like Pluto, I wonder?
That's a very good question. People looked at Pluto and said, Pluto's got a satellite, that makes it different. But now, in fact, there are about 10 objects that have been detected so far that have satellites as well. Pluto now has 3 satellites, of course, with the 2 very small satellites that have just been discovered. However, one of the very large Kuiper Belt objects that was discovered just recently, 2003 EL61, also has 2 satellites. One quite large one that was detected very quickly, and a smaller one has just been detected as well. So Pluto isn't even unique in having multiple satellites. And that has been a very big surprise, the fact that so many of these objects do appear to be double or even triple bodies.
When will the New Horizons fly past Pluto?
Well, it should reach Pluto and the Kuiper Belt in summer 2015, if we're lucky. Now, there is a possibility that if the launch is delayed, it could miss its Jupiter flyby and it will arrive much later. The plan at the moment, everything seems to be going well with the mission, is to reach Pluto and Charon, do a good mapping of the surface, the geology, investigate the ring system, if there is a ring system, and any small satellites that may exist. And then it's going to go off into the Kuiper Belt, and in the following years, the idea is for it to go to several Kuiper Belt objects and have a look at various bodies that are smaller than Pluto and see what the similarities and differences are. Now, that is going to be fascinating.
Will it finally leave the solar system, as the Voyagers will?
Yes, it will. It will finally leave the solar system. It will go on its way out there. The Jupiter flyby, I'm afraid, makes that absolutely inevitable, and it will leave for good. But on the way, it's going to be able to visit a fair number of objects.
What images of Pluto do you expect back?
That's a very good question. I don't. If I knew the answer to that, I think I'd be a fortune teller. I suspect that it will look similar to the icy bodies that we've seen all around the outer solar system. The satellites of Jupiter, Saturn, they all look very similar. They're very much ice, very battered surfaces, extremely cratered. Some of them are so cratered that there is no smooth ground anywhere. It may even be that Pluto has actually been broken apart in the past. That one of the theories about the formation of Charon, its satellite, is that something came along, bang, hit Pluto, Pluto flew apart, one of the fragments reformed into Pluto, and another of the fragments turned into Charon. The fact that there are also some small satellites there may actually support that idea. So we may actually find that Pluto looks much more battered even than most of the satellites of the outer solar system.
Let's say a bit more about the Kuiper Belt. For example, how did it form?
Well, essentially, in the planetary formation process, we start off with very small pieces and build up gradually to very large pieces. That's a great simplification, and the details aren't always fully understood, particularly at the small sizes. But once things get relatively large, they start clumping together due to gravity, and that means they need to have close interactions. And in the inner solar system, that's quite likely to happen where the orbits are relatively small. Now, for the Kuiper Belt, we're talking about a kind of current distance of Neptune, 30 astronomical units, out to, in circular orbits, at least 50 astronomical units, and in eccentric orbits out to several hundred. Now, there's an awful lot of empty space, and there just hasn't been enough time, essentially, to allow a single planet to have formed out of all this material given the fact that the inner planets had formed and started stirring up the material outside.
I think things have changed a bit. Originally, people thought of the Oort cloud as the material left over from the formation of the solar system. The ideas are changing. What people think is that comets were actually formed a lot closer to the Sun than was originally thought. Many of them were probably formed between the orbits of Saturn, Uranus approximately. And then perturbations from the planets swept this material out to form a belt around the distance of Neptune, which is the Kuiper belt. Now this Kuiper belt starts at Neptune and then goes right out to about 10,000, 12,000 astronomical units. That's a fairly arbitrary point. And at that point, the gravitational pull of the Sun is so weak that no longer does it stay in a thin plane, that it starts to spread out, the perturbations from nearby stars become strong, and then it spreads out at that distance into the big sphere that's the Oort cloud. And the Oort cloud is not actually permanent. We lose it from time to time when we go through big clouds of dust and gas in the galaxy. And then it's replenished from the Kuiper belt. We believe that most of the objects are actually in the Kuiper belt, not in the Oort cloud.
Now let me come now last to the one knotty problem. I'll put it this to both of you. I've got my own ideas here. We always regarded Pluto as the 9th planet, but is Pluto a planet? What do you think, Simon?
I think it isn't a planet. I think it's just one of the larger Kuiper belt objects. But given the history of the nomenclature, and we've all grown up being used to thinking of Pluto as a planet, and I think we shouldn't change that, but we shouldn't name any more. We'll have not only Planet 10, Planet 11, Planet 12, Planet 13 very, very quickly. So I think it's not a planet.
What do you think, Mark?
Well, I remember in 1979, you sent me this as an exam question in Queen Mary College. I said, yes, it was a planet, and I was wrong. It is not a planet. I'm not as optimistic as Simon. I think that many more of these objects larger than Pluto, and it's going to be very, very difficult to maintain the fiction that Pluto should be kept as a planet.
It isn't, I'm afraid. It's not a planet. I'll nail my colours to the flag. I'm talking about planets in our own solar system. And I would define a planet here as being a spherical object going around the Sun and as large as or larger than Mercury, which is just over 3,000 miles across.
I think you'd find, Patrick, that quite a lot of people would be sympathetic with that view.
Anyway, Pluto's there, planet, KB or not, it's a fascinating world. Mark, Simon, thank you very much. Well, it's newsletter time. If you want your newsletter, then send your stamped addressed envelope to the following address: The Sky at Night, Newsletter 100, BBC Birmingham, the mailbox B11RF. And when I come back next month, I'll be going with Chris to the top of Mauna Kea in Hawaii to visit one of the world's really great observatories. So until then, good night.